Now we have come to the last chapter of our flight control, this control system. The chapters that we will be going through are control systems, classification, terminologies, open loop control system, closed loop control systems, controllers, types of controllers, quadcopter an example. Control system design. Simple flowchart indicating the basic element in designing of new product shown here. The design is divided into three phases, that is conceptual design, preliminary design and detailed design. So first, to start off, to design a control system to handle the altitude of the flight. The altitude is dependent on the elevator pitching moment. So first, as soon as we come to know that we have to design a control system to handle the altitude of the flight, we have to go to the elevator for pitching moment. Under elevator pitching moment, we have to have a condition that lift should be at 0 angle of attack and the stall should be beyond 16 degree. If this is decided, then we can go on to the conceptual design of the elevator and then do the wind testing for the same. After the wind tunnel testing, we have to do the mathematical hand calculation of consistency of elevator to reach the height that we desire. After mathematical hand calculation, we have to evaluate the performance of the elevator, whether it is up to the control concept and analysis tool, that is software tools. After that, we have to decide whether the concept meets the system performance and specifications and requirement. So if it meets, then we have select the best design concept based on estimated cost, simplicity, reliability, ease of manufacturing, and then we move on to the preliminary design. If it does not meet the system performance, then we have to decide whether can the concept be improved by system compensation. If the concept can be improved by system compensation, then we have to evaluate the performance of the elevator and again do control concept in analysis too, and then again verify whether the concept is meeting the performance specifications and requirement. If the concept is not approved by the system compensation, then we have to go all the way to the conceptual design of the elevator and redo the wind tunnel design and the conceptual design of the elevator. In the final design phase, engineering team develops the detailed drawing and stipulates the manufacturing details. Control system. Control means to regulate, to direct or to command. Hence, a control system is an arrangement of different physical elements connected in such a manner so as to regulate, direct and command itself or some other system. So here we have the input signal is an error signal, which is the difference between the measured variable and the desired value. The diagram here is a closed loop system which is represented with various signals, that is reference input, control error, control input, controller, disturbance input, noise input, target system and measured output. And we have a feedback loop which says transducer and transduce output. So feedback is a property of a system by which it permits the output to be compared with the reference input to generate the error signal based on which the appropriate controlling action can be decided. So depending upon the nature of the controller and it is required to reduce it or amplify it or change its nature, that is make it discrete from continuous type of signal. This changed input as per requirement is called a reference input, which can be generated by using reference transducers. The part of the output which is to be decided by the feedback element is fed back to the reference input. The signal which is output of the feedback element here is called a transduced output. It is also called as a feedback signal. When the feedback signal is positive, the system are called positive feedback system, and if it is negative, systems are called negative feedback systems. When the feedback signal and the input are in the same phase, then the feedback is called positive. When the feedback signal and input are out of phase, means having a phase difference of 180 degree between them, then the feedback is called negative. This error signal is then modified by the controller and decides the proportional manipulated signal for the process to be controlled. This manipulation is such that the error will approach zero. This signal then actuates the actual system and produces an output. As output is controlled one, hence it is called a controlled output or a measured output. Control system classification. Control systems are classified into natural and man-made. Man-made is then further classified into manual and automatic. Automatic control systems are of open loop and closed loop. Under open loop, we have linear and non-linear. Under closed loop, we have non-linear and linear, where non-linear is again divided into time variant, time invariant, and linear is divided into time variant and time invariant. Let us look at an example for each. Natural control system. We have universe and human body. The biological systems, the system inside a human being, are of natural type. For example, the respiration system inside the human being is a good example of natural control system. This system activates the secretion glands, secreting sweat, and regulates the temperature of the body. Then we have man-made control system like vehicles and aeroplanes. The various systems we are using in our day-to-day life are designed and manufactured by human beings. Such systems like vehicles, switches, and various controllers, etc. are called man-made control systems. Manual control system, we have water level control and room temperature regulation via electric fan. In this case, the human, that is the operator, interaction will be present. The tap will be in control of the operator. The moment the tank fills, the operator manually closes the tap. Whenever the tank level decreases, the operator again opens the tap. This process goes on and it is called manual control system. Automatic control system, again we have human body temperature control and room temperature regulation via AC. In this case, the human, that is the operator, will be replaced by a level sensor and a microcontroller. The level sensor monitors the level of the tank continuously and feeds the level data into the controller. When the level reaches to the maximum, the controller sends a signal to the valve and closes it. So this is automatic control system. Open loop control system, we have a washing machine and toaster. So basically, open control system in which the output is dependent on the input, but controlling action or input is totally independent of the output or change in the output of the system. And then we have closed control system like refrigerator and autopilot. So a system in which the controlling action or input is somehow dependent on the output or change in the output is called closed control system. Then we have non-linear and linear control system. The output does not vary linearly with input signal is called non-linear control system. It does not satisfy the principle of superimposition. The output does not vary linearly for a non-linear system. Then we have a linear system where the output varies linearly with the input signal. The principle of superimposition is capable of the system, which means that the response of several inputs can be obtained by considering one input at a time. Invariant and time variant. If the input and the outputs are functions of time, but the parameters of the system are independent of time, which are not varying with time and are constant, then the system is said to be time invariant. At the same time, if time varying control systems are those in which parameters of the systems are varying with time. It does not depend on whether input and output are functions of time or not. I hope you would have understood the basics of control system. Let us move on to some terminologies in the next session. Thank you.